Hello, my name is Jisoo Im. I'm a master's student at Ewha Women's University. I'm studying biomedical engineering, especially focusing on biosensor. Today, I would like to talk about sex-based differences in biomarkers and its application of biosensor. Do you know that every 36 seconds in the United States, one person dies from cardiovascular disease? Even in this era of COVID-19, heart disease was the number one cause of death globally. It's also the number one killer for both men and women. Regardless of sex, if we are at risk for a heart attack, we all get the same test called gold standard. However, this test was initially designed and tested only in men. So it's of course not as good at determining that of women. The gold standard test was not gold for us. Then what are we missing here? The consideration of sex and gender. This has been overlooked in medicine so far, but there are significant differences down to the cellular and molecular levels between men and women. Sex, as a biological determinant, could be just simply said DNA. Every cell in our bodies, like heart, lungs, brain, contains our own unique DNA, which not only determines whether we become man or woman, but also remains active for our entire lives, causing differences in diagnostic, prognostic, and therapeutic aspects, such as individuals' different response to certain drugs and risk of developing particular diseases. Gender is how someone presents themselves in society. So this could not be simply measured by sensors, but could be captured in part through modeling the epigenomes or environmental exposures. So today, I'll mostly focusing on sex-based differences, which can be detected by sensors. Then you might have come up with a question of how. Before explaining that, let me briefly introduce what biosensor and biomarkers are. A biosensor is an analytical device converting a biological reaction into a readable electrical signal. Using biological components such as DNA or proteins like antibodies or enzymes, it detects a target analyte, the biomarker. Biomarkers are biological molecules found in body fluids like blood, which are used to measure the presence or progress of diseases or to monitor the effects of treatment. And this is where the sex difference comes in. It can affect the threshold concentration of biomarkers for diagnosis, because what is considered to be normal in one sex may be pathologic in the other. According to recent studies, there were considerable differences in circulating biomarkers of cardiovascular disease between the two sexes. For instance, markers of cardiac stretch were higher in women, whereas markers of cardiac injury and inflammation were higher in men. It suggests that there is the presence of various sex-related pathways involved in the development of the disease. And for detecting these various biomarkers in very different concentrations, biosensors, especially magnetic nanobiosensor, which are used for my research, could be the most reliable and cost-effective tool available at present. It's a biosensor using magnetic nanoparticle as a label. It produces an electrical signal when it detects the presence of target analyte by the effect called magnetoresistance. Compared to other fluorescent dye-based optic sensors, it has a very low background noise level. And also it's insensitive to temperature, pH, and salinity. These characteristics make the platform highly sensitive and robust quantitative measurement. Today, I talked about how women and men are biologically different and how this affects in medical and clinical aspects. Also, I introduced my research background of biosensors and its application on this topic. Before I finish my presentation, I would like to highlight once again, women are not just men with uterus and breasts. We have our own anatomy and physiology, which cause tremendous differences in the mechanism of diseases, and it deserves to be studied with the same intensity. And for this, magnetic nanobiosensors could be a great choice. Thank you for listening.